Good morning, students.
Morning, sir.
Okay.
Sir.
Yeah, good morning. So tomorrow, sorry, not tomorrow. Yesterday we did a numerical, no? Hello, hello.
Yes, sir.
So did you do the numerical? I guess
Yes, sir.
some of you have done.
Yes, sir.
Yes, sir.
Okay. So the answer is 519.16 Newton meter. Did you get the answer? 519.6 Newton meter.
Sir.
Okay, Ansari has got the answer.
Yes, sir.
Hmm. What about others?
Two, sir.
Hey, Mazar, you got?
Yes, sir.
Good. So what I am asking you to do is, what about others? Yeah. I'm asking everyone, what about others? Did you do the numerical?
Sir.
Yeah? Did you do the numerical?
Yes, sir.
So, so only one said yes. Rest I don't think should have done. What answer did you get, Vidyasagar?
Done.
What answer did you get? Just write in the chat box. Is it matching with mine? Are you able to see the numerical? Are you able to see the numerical, students?
Sir.
Sir.
Yes, sir.
So did you get the question? This is the question, na?
Yes, sir.
So this is how it is done. So if anyone has not done, you can just note it down how it is being done. Do I need to explain it to you?
Sir.
Anyone? Do you need explanation of this numerical?
Sir,
Huh? Yes, Valentina.
I didn't attend the class, so please explain it.
You do not attend the class, so I have to explain it again.
So only this part.
Huh?
So only this question.
This question. Okay. Listen now. So what is given in this question? A force of 200 Newton. So this is the force P, 200 Newton. It is acting at a point B. It is acting at a point B. So this is what? This is the point B. Okay. So this force is acting at this point. So we have to determine what? Determine the moment of the force about O. Now look, we have discussed the moment of force is force into what? Perpendicular distance, right? If force into perpendicular distance between, so what happens? Now look, we have to find out this is the force and this is the distance given, right? So now this is the distance given. Now look, from this point, okay, from this point, this force is inclined at an angle of what? 60 degree, right? Now look, the perpendicular distance should be the distance between point O, that means this point, and the line of action of this. That means what? We have to measure this distance for the perpendicular. So for measuring the distance of this perpendicular, how you can measure? You know this one is 3, na? Now if you know this 3, then this is what? This is OB. So OB is this 3. Now if we have to know the cos theta component of something, we all know like this, no? We know like this. If something is like this, now if this is F, suppose, so this is what? This is F cos theta. Yes or no? If this is theta, then this is F cos theta, and here it will be F sin theta. Now look here, this is suppose F, this is F, so OB is F. Now OB cos theta, OB cos 60 will get you this distance, no? OM, you will get this distance. That's it, as simple as that. So if you take this cos theta component, or you can just note it like this. Cos theta is what? Cos theta is equal to what? Anyone tell me what is cos theta? Yeah, no one is there.
Adjacent side by hypotenuse.
T
Where is
by
Valentina?
Adjacent side by
Base by
hypotenuse.
perpendicular. Sorry,
Base by
base by
hypotenuse.
hypotenuse. Base by
Hypotenuse.
hypotenuse.
Where is Valentina? She asked me the question, na? She disappeared or what?
No, sir, I'm there.
So cos theta is what? Base by hypotenuse, right? So
Yes, sir.
yes or no?
Yes, sir.
So that means what? OM. So that is why we got OM. That means OM is equal to OB cos theta. Simple. Okay. So OM equal to OB cos theta, and eventually we put this answer like this. P is given here 200. So this cos theta we know. So this is like this, and we get the answer like this. Clear, everyone? If anyone is having problems with the mic, please mute your mic. Okay. There are lots of noise coming. So let us go to the next numerical today. Valentina, is it clear? Valentina, is it clear? Yeah. Is it clear, everyone?
Yes, sir.
Yes, sir.
For me, it's yes, sir.
Okay, fine. No one is responding. Let others sleep. Someone is leaving and joining the meeting. That's what they are doing. Okay. So write the next question. A force of. Let me do it. Write this question. A force of 200 Newton is acting at a point B. A force of 200 Newton is acting at a point B of a lever AB. Are you able to see the question?
Sir.
I think.
Okay,
Ah,
good, good. You should write it actually, because I will give you the PDFs. Then I will understand who is taking part in the class. If you don't write, I won't give the PDFs. I'm telling you, everyone. If you don't write, there's of no use. A force of 200 Newton is acting at a point B of a lever. Look, for acting at a point B, right? So what is point B? This is the point B. Okay. This is the lever AB and this is the hinge part. So what you have to do is you have to find out the moment of the force about the hinge end. So how will you find the moment about the force about the hinge end? Yeah, if you are done writing, Ansari, tell me, okay? Ansari and Azad.
then it's over, sir. हो गया.
Okay, yeah.
Yes, sir.
And draw the diagram also, huh? Everyone, I'm telling you. Draw
That's
this diagram.
हो गया, sir.
हो गया? अच्छा
No, sir,
ठीक.
no, sir, no, sir.
No? Okay, wait. I'm waiting. You can just draw it.
Finish. Sir.
Finished. Have you drawn the diagram?
Yes, sir.
Okay,
Yes, sir.
good. So what is this? Look, if you pay attention now, what we need to find out is, this is not the method, okay? Do not copy the answer. Can all of you try? Not, this is the method that we will do. We will do it later on. Okay, this is a bit more complicated. So can you try out solving? Any idea how to solve? Students, any idea how to solve? Can anyone say anything? How will you solve this?
So which one is M?
Uh-huh. What?
M वो P perpendicular into
तुम्हारा
equal
वॉइस क्लियर नहीं आ
point.
रहा है मैचुबा, वो चैट पे लिख के दे दो, ठीक है? मैचुबा, are you hearing me? Write in the chat. I'll have a note of it. What AM? Mechuba?
Perpendicular into वो A ना वो force into perpendicular distance between point
हाँ
A and the line of action of force.
हाँ,
उसके बाद नीचे वाला B into A M into constants.
तुम्हारा थोड़ा ठीक है, हम लोग क्या करेंगे पता है? Look at it, हाँ? How will you do it? Now look, this is B now. Yes or no? So now if this is
Yeah.
B,
Yes sir.
this B will have what? This B will have one side here, X component. That means X. This one is how much? This one is 200, no? So here it will be 200 now.
100.
So if this is 200,
Yes sir.
so this side it will be what? This side will be, this side will be, I'm writing it here, okay? 200 cos 60. Yes or no?
Kita
Yes or no?
60.
है
Yes
कि
sir.
नहीं? तो ये साइड में
Yes
हमको
sir.
क्या मिल गया?
Yes
We
sir.
get the force now here in this side. Yes or no?
Yes sir.
Okay. So after that, we got the force only, huh? So force in x direction, write it down. Force in x direction. This is 200 cos 60. Now similarly, what will be in y direction? Can you tell me the expression for y? What will be the
200
force?
sin 60.
Very good.
200 sine
200
200 sine
sine
60 degree. 60 degree.
Very good. Very good. Good.
yes sir.
So now, if we know this side will be what? I'm just writing it down. So this side will be 200 sine 60, right? So if this side will be sine 60, so you got the forces in both sides. Yes or no? Yes or no? You got the force.
Sir.
Now what will happen?
Sir.
Look. So we got up to these two steps. So we will do this method, alternative method. Okay. So look, we have got up to this one and we have got this one. Yes or no? Now we all know. Now you can write this one as a note. Just write a note. Just write a note and write this line. Write this part. That from Varilon's theorem, moment of a given force about a specified point is equal to what? Sum of the moments of its components about that point. So now we will find out the individual moments. So now what happens? Look, if we have got px means what? This one let us think as f of x. Okay, and here let us make it what? F of y. Okay, so f of x and f of y are different, right? So if f of x and f of y are different, then we can find out the moment about x. F of x what? 100. So this one is 100, no? Now if you look at this diagram, just pay attention now. We are getting this component as x component and this component. And okay, this is the x component and this is the what? Y component, right?
Right, brother. Yes, sir.
So how did we do that? Now look. So if we got the x component like this, so here it will be x and here it will be y, right? Now look, if we got this in x, p of x equal to how much? It came out to be 100, na? To if it came out to be 100, so force, what is moment? Look, now this is the force. Now this distance cannot be the perpendicular, but this is the perpendicular distance, right? 0.4 meter to a.
Yes.
Yes or no?
Yes.
So this is the force. This is the force in x direction, and this is the perpendicular distance, right? If this is the perpendicular distance, so what happens? If this is the perpendicular distance, then this is the perpendicular distance. This come out so to be how much? 0.4 meter, na? So what we did was,
4 meter.
so this one is f of x. So force into perpendicular distance. Similarly here, look, here we have got what? It is the sin theta component, na? Sin theta component. So f sin theta. So if this is f sin theta, then what happens? This is the perpendicular distance, na? So how much is this? This is 3 meter. So the force component in x and y comes out to be like this. So it is like this. We got this. Now look for the minus sign. But here it is given, look, force is equal to the sum of the moments, no? So why the minus sign? Look, this is only because of the direction. Here we have one and here we have one. So now if you find out this one, here it is cos theta is fine, but sin theta is what? It is going out, no? So if it is considered to be minus, okay? the sin theta component is considered to be minus. So that is why we got this answer. Okay,
Okay, sir. Thank you, sir.
is it over?
Yes, sir.
No, sir. Minus.
Yes, sir.
About the minus sign.
Hello,
Hello.
hello.
Sir, can you repeat once again about the minus sign?
Okay, I'll say it. Wait. Look, have a look at it. Now, if you say it here, suppose this is the cos theta component. Okay, so this is the cos theta component, and what is this? This is the sin theta component. Okay, now look. Now if you see here, now here for this part, this is in this direction, right? Force is in this direction, right? So now force into perpendicular distance, that means what? This distance into this side. So this is the moment in this direction, and for the cos theta component it will be in this side, right? So now if you see here, just pay attention. I'm explaining to you in another way. Okay, look, this is the arrow now. If you have to come to this side, you have to come to the left side now. Yes or no? Yes or no? This is in
Yes, sir.
this now just pay attention. This is, I'm trying to explain it to you in another way. So you have to come in this direction, right? That means what? This is the left side of the arrow, right? And here, if you see here, look, if you see here, this is the which side of the arrow? Like, if you rotate your screen and see it, this will be the right side of the arrow, no? But this will be the left side of the arrow. Yes or no? Yes or no? So what happens?
Yes, sir.
Uh,
Yes,
so
sir.
if this is the left side, so look, if the directions are opposite, uh, if the directions are opposite, then what you'll have to do? You have to consider one as positive and the other as negative. As simple as that. Now here, this sin theta component, that means this is the sine now. This sin theta is in the left side. I mean, if you find out the moment, you have to come to the left side. So this is considered as negative. So we have got minus 173.2, and here, look, this is the right side. We have to go here now down. So this is considered as positive. So we have got this as what? Positive. Is it clear now? Is it clear now?
Sir.
Yes, sir.
Who asked me? Someone asked me, na?
Yes, sir. It's clear.
Is it clear? Okay, you got
Yes,
it, na?
sir. Yes, sir.
Just think of the direction, okay?
Ye-
Just think of the
Yes, sir.
direction, then you will get it. Okay? So now look,
Yes, sir.
this is what we have got the answer, right? Minus 11.96. Now look, since it is the answer is overall minus, since the answer is minus, that means what? the resultant moment will be in the opposite direction. That is why we have considered as anti-clockwise. Just remember it. Clockwise is positive and anti-clockwise is what? Negative. That is why we are writing it as anti-clockwise. Clear? Is it clear?
Yes, sir.
Good. So now what you do is, have you written the question and the answer? Students, have you written down the question and
Sir.
the solution?
Sir.
No.
Only the question.
You want to, did you remember the solution or you want to write it?
I think it's okay, sir.
Still bit, sir.
Okay. You take a screenshot of it, then you can remember it. Nah?
Sir.
Take a screenshot of it, you can remember it then. Just take this diagram also, then you won't be or else you won't be able to understand this diagram. Okay? Okay. So shall I close this?
Okay, sir.
Yes, sir. You can.
Yeah. Now let us go to another topic now. Scalar product of two vectors and its applications. So what is a scalar product? And of two vectors and its application. This is simple. Now here it is P and Q. This is P. This is P and this is what? Q. So these are what? These are two vectors. Now if you do scalar product, that means what? It will be as a dot. You can see a dot here, I guess. So it will be as dot. So if it is scalar product and if you do is dot, then it is cos theta. Okay. So now look, this is the P vector. Now if P is there, so we have to distribute the vector into three parts: Pxi, Pxj, and Pxk. Similarly, we have distributed Q into three parts. That means in three dimensions. Okay. So that similarly Qxi, Qij, and Qzk. Now look, if we have to find out PQ. PQ is what? PQ cos theta, P dot Q. Okay. So now, and cos theta is given by this expression. So that is how, this is how we do the projection of the vector. Okay. So this is a simple thing. Just remember the expressions. Okay. The numericals are much more important. So how projection of vector along the direction. So POL, angle P, this is the center point O. So along the direction OL, the projection is PC cos theta. This is how we project a vector. We have to do this numerical. Just do one thing. We'll discuss this numerical now. We have okay, let me discuss this numerical today. So we'll solve it, try to solve it in the next class or something like that. Look, this is what? A single force BC a single force P. A single force P. Are you able to see this, students?
Yes, sir.
Yes, sir.
Yes, sir.
A single force P. So this is the force P. Okay. So this is the force P. It is acting at C in R direction, perpendicular to the handle BC. Now it is acting at C and this is the handle now. So this is the handle. This is perpendicular to the handle. Now knowing that mx is equal to 20 Newton meter, my is equal to minus in the x side it is moment at x equal to 20 Newton meter and moment in y is equal to minus 8.75 Newton meter and moment at z equal to 30 Newton meter. So from that moment you have to this time determine what the magnitude of P. P means what is the force, the single force and the angle at which the force is acting. Okay. So what you can do is I'll just write the question in the chat. Okay, I'm just copying it. Let me see. And if you just draw the diagram, okay. So we'll do it in the next class. Okay, this one. I have to try doing it today. If you can't, we'll discuss in the next class. Just simply draw the diagram. Can you draw it, students? Or take a screenshot, whatever you want. I've given the question in the chat box. Just check it out. Is it okay? Are you able to?
Yes, sir. Yes, sir.
Sir.
Hmm.
Yes, sir.
So this is 100, okay? This is 100 mm. This is 150 mm. This is 200 mm. You just try to solve it, okay? If you can't, this will be a difficult sum. This is a difficult sum. I know it might be not. It might not be possible for you. Then we can discuss in the next class. Okay? Poonam, I'm not asking you to give the attendance, no? Hemchandra Poonam, Paunam. Did you understand Hemchandra Paunam?
Yes, sir.
Did you attend the class?
Yes.
Did you write a question and this numericals? Did you understand?
I am copying, sir.
Okay, okay. You no need to copy it. Just take a screenshot. It will be easy for you only. Okay. Yeah, just give your attendance in the chat box, everyone. This is over now.
Sir.
Mm.